The last thing I'd like to do is to show you the pressure volume diagram for an internal combustion engine. So I take you back to this animation that we saw at the very beginning, in which I have a piston that's moving downward and upward and downward and upward in a 4-cycle engine. So what I end up having is an intake stroke, a compression stroke, a power stroke or combustion stroke, and an exhaust stroke. And let's look at the pressure volume diagram for this particular type of engine. What I have here is an idealized Otto engine. Otto is the name of the German fellow who described this cycle for an internal combustion engine. I'm going to let this animation play, and as it does, I'll describe what's going on. You have a piston which is connected to a crankshaft. The crankshaft is the circle that's down at the bottom. The piston is this red rectangle that in cross-section is really cylindrical, that moves up and down inside this blue hollow space, a cylinder. And what you have happening is the pressure volume diagram being traced out with this red dot that's moving around as the piston and goes through its cycle. So let's talk about the different parts of the diagram and then look at the cycle again so that we can follow what's going on. In this diagram, what we see is that we have an intake side, we have an exhaust side, we have this piston, this red thing that's connected to the crankshaft by this connecting rod, and I have a spark plug up here that's yellow that serves as the place that ignites the fuel. Now what's going on during this process? In this particular animation, the process begins with a power stroke. So what's ending up happening is that I have the spark plug ignited and it's pushing the burned gasoline downward. I'm pausing it at a moment here, and you see that this is an expansion and work is being done by the gas on the piston. That happens to be an adiabatic expansion. So what's happening, this crankshaft is actually turning several tens of times per second. If you're driving down the interstate at, say, interstate speed, and your engine is turning over at, say, 2400 RPM, if you have a tachometer you can see that. Well, if there are 2400 revolutions per minute and there are 60 seconds in a minute, then that means there are 40 revolutions per second. Your crankshaft is turning 40 times per second, which means that you're getting 20 pushes on this piston from each cylinder every second. This process is happening very, very quickly, and there's not a lot of time for heat to be removed from the cylinder during one particular process, one particular explosion. So this is considered an adiabatic expansion. Now we'll let this thing play a little bit, and you're going to see that the exhaust valve on the right opens up. So what happens when I pause just for a moment, you'll see that this gray gas that's here is being expelled out the exhaust side, and so you get a little puff of exhaust gas, carbon dioxide and water, and then other gases that are incompletely burned that are coming out of the exhaust manifold and out the exhaust valve. So that's the exhaust stroke, and you can see that this red dot is moving to the left as it exhausts. Now what happens is that once the exhaust is gone, the intake valve, which is on the left side here, opens, and I get some gasoline or diesel fuel mixed with air that is being pulled into the cylinder. And as it is being pulled into the cylinder, then the volume increases. That happens isobarically at atmospheric pressure. So I have an isobaric process, and just at the bottom of the stroke the intake valve closes, then I'm going to begin the compression stroke. This is going to be an adiabatic compression, and now that compression causes the gas to change its volume. It's becoming compressed, and so the gas molecules are very, very close together. And now I'm going to step very slowly up to the very top of the compression stroke. And once I get to the very, very top, which is sometimes referred to as top dead center, the spark is going to ignite. Now I want you to notice where this dot is down here. When I step one more step, now the spark's going to explode, and all of that gas is going to suddenly exert a very high pressure. I'm going to have a few moles of gas being changed, a few moles of, say, octane being changed into about 8 to 10 times more moles of carbon dioxide and water plus other gases. So there's a huge pressure increase all of a sudden. Here we go. There. I have an isochoric process. The pressure has suddenly gone up at constant volume there, and that is the instant at which the spark ignites. That gas now is at very high pressure, and it undergoes this power stroke, and that power stroke is what pushes the piston downward. That's where you get your push, and I have an adiabatic expansion. Once it gets down to the bottom, now the exhaust valve opens again. I get the exhaust pushed out, and that's the exhaust stroke. So now I'm at the top of the exhaust stroke. Now I'm in the compression, the intake. So this is the intake stroke. Now the intake valve closes. I get the compression stroke. And right at the very top of the compression stroke, bam, the spark plug ignites. And now I have the power, or the combustion stroke. I'm pushing the piston down. There's my push. There's where I get my power. Now the exhaust valve opens, and I push the exhaust out. So again, intake, compression, power, exhaust. Intake, compression, power, exhaust. And this is happening at 40 times per second as your car moves along. We'll label this diagram here. In the intake stroke, what's happening, my dot is right here. In the intake stroke, I am allowing gas to come in, so that is happening along this part of the stroke. So this is the intake stroke. During the compression stroke, the start of the compression stroke is here, and the end is right there. So what ends up happening on this PV diagram is I have an adiabatic compression. Right at the end of the compression stroke, I have the ignition. This is where the spark plug ignites, and I have an isochoric increase in pressure. Now, that point that's up there at the top is the beginning of the power stroke, and down here at the bottom is the end of the power stroke. And so what ends up happening is I have an adiabatic expansion. So I have an adiabatic compression happening here, and an adiabatic expansion that's happening here. That's my power stroke. And then during the exhaust stroke, what ends up happening, the exhaust stroke begins here with the exhaust valve opening. Pressure drops all of a sudden, and then so the exhaust stroke begins with this isochoric process in which the exhaust valve opens, and then I have an isobaric expulsion of the gas, and that will be the end then of the exhaust stroke. So going up to our large diagram up here, I will label the different parts. So here is my labeled PV diagram. There's the first. It's isobaric. The intake stroke ends, and then I have compression. The compression is adiabatic, and at the end of the compression stroke, the spark plug ignites. That's an isochoric process. Then I have my third stroke, which is the combustion stroke, or the power stroke. It's an adiabatic process. And then finally, at the end of that process, the exhaust valve opens, which allows a drop in the pressure all of a sudden. That's an isochoric process. And then the piston pushes the gas out. That's an isobaric process, and the cycle begins again. Intake, compression, spark plug ignites, power, exhaust. Intake, compression, power, exhaust. And that's what it looks like on a pressure volume diagram. You do not have to know the Otto cycle for the AP exam, but here is a practical application of PV diagrams. So for now, that's it.